So first and foremost, what is the example we have taken? This is the example. Okay? It's a classic example of what you see in the internet. Okay, what is the example? The example talks about 5 transactions. You got one T1, T2, T3, T4, T5, and these are the items that are brought. Okay, the each alphabet will be sort of representing an sort of item. The first frequency of each individual items like this. Okay, so that was the first step, right? So the first step was all about figuring out the each individual frequencies of it. So what we did the same thing like this. So you see, the first step was always to figure out the each individual frequency. We got the each individual frequency to be like this. Then what was the next step? The next step was to make sure that whichever have the support, minimum support of less than 3. Why we are taking less than 3? Very simple. Because minimum support, we have taken it as 3. You can see very clearly see that we have taken the minimum support to be 3 here. And now what is our job? Our job is to make sure that whichever has a minimum support of less than 3. Okay, minimum support of less than 3, those things will be taken out. Those things will be sort of removed. Okay, a frequent pattern is built which will contain all the elements whose frequency is greater than or equal to the minimum support. So we'll be building a frequency pattern set. Be careful, I'm talking about frequent pattern set. So only it's called FP, frequent pattern. Okay, so we are going to build a frequency pattern such that it is greater than or it is equal to the minimum support. What is the minimum support? We have 3. So we need to build in such a way that, of course, we need to build it in descending order. That is what it clearly say here, that we need to going to build it in descending order. Okay, and what is the respective frequency will be? It will be like this. Okay, you are going to have it in such a way that, and you can very clearly see, okay, what are the ones that is having more than 3? You have something like a K which is having 5. Okay, before that you have E which is having 4. Okay, then M 3, then O is 3, then Y is also 3. Okay, so that's what we have done, and we have written all those things in descending order like this: 5, 4, 3, 3, 3. Now people may be thinking how it is, M O Y, because I have written this in as a alphabetical order, M O Y. Okay, now for each and every transactions, this is the most important step that I'm supposed to write. Okay, for each and every transaction, see, all those people who are not there, please go back and check previous days videos. Okay, that's why every sort of session is recorded, so that you people will always go there and check. Otherwise there's no point, right? Make sure that you people are looking into it. Now for each and every transaction, see, this is the original transactions. This is original transaction. This is the original transaction IDs. For each and every ordered item set, okay, we are going to write what is known as an ordered item set. Now, what is the way of, from here, how it is changing to here? Very simple. Okay, we are going to take what is known as, one second, I'll just open the whiteboard. Once, the whiteboard opens, I'll show you. Okay, or else it's very simple. Okay, you can make up right from here. EKMNOY is the original transactions. Okay, how do you write the ordered item set for it? We can write the ordered item set in a very simplistic way like this. How? First and foremost, you write everything. Okay, EKMNOY. In this, what are the ones that are needed? Only these things are needed. Okay, so K will be there, no problem. E will be there, no problem. M is there, yes. M will be there, no problem. N, see, you can see very clearly on this, N is not there. Frequent patterns, in frequent pattern, N is not there. So obviously N will be removed. If N is removed, what are the two things that are remaining? O and Y. Is there O and Y here? Yes. So all those things will be coming here. K, E, M, O, Y. People may be thinking why its K is coming first, because I need to write it in descending order. So you can see very clearly the same things will be coming right here. K, E, M, O, Y. Then you go to T2. Okay, T2. You have D, E, K, N, O, Y. In that, what are the ones that are needed? Is there K? Yes. So I'll write first K. Then I'll check for E. Is there E? Yes. I'll write E. Is there N next M? Is there M here? No, there's no M here. So no M will be coming here. Okay, then O. Check for O. Is there O here? Yes. So that O will be written here. Y? Yes. So this will become K-E-O-Y. Like this, you are going to write for each and everything. Okay, you are going to write for each and everything ordered item set KEMOY, KEM, KMY, and also KEO. Okay, so for each and everything, this is written. Now we need to go write what is known as a tree for this. How do you think this will be done? This will be done like this. Okay, you are going, first thing is you are going to write a tree arrowed item set for it. You are going to start right from null. See this null. Then you are going to write a neat tree for each and every transaction. The first transaction is KEMOY. So that is written very clearly here, KEMOY. Okay, KEMOY is written. The second transaction you look for, the second transaction is KEOY. Okay, so KEOY is the next transaction. Now in this, what needs to be done? This is again the next part where you have to be very careful. Okay, so now they're saying KEOY. Okay, K is here. So you're going to increment that. So that this K equal to 1 will become 2. KE. So there's a direct connection here. So this will become 2. Then OY they're talking. Now there is a M in between. You can't go from K to E to O here. There is a M in between. So what needs to be done? Very simple. You are going to create one more node for O. Okay, you are going to create one more node for O, and that is what you're going to see here. Okay, so you can see very clearly that KEOY, right? When I'm trying to insert the second one, this is the second transaction, second ordered item set transaction. When I'm trying to insert this, what I'm trying to do, K and E will automatically become 2, 2. Not a problem. Okay, it is not a problem. K and E will automatically become 2, 2. Next thing is, you have got K and E got, next is this M is not there in this. So what needs to be done? Very simple. I need to create one more node for it, O. See, I'm creating one more node for O so that, and with the increment value of 1 or the value of 1. Now you see the path K, E, O, and of course I need to go for Y also. So I will be creating one more Y with regard to this. So K, you can see the path now. See the arrow that is being written in dark letters. Okay, K, E, O, Y. Second part is also done. Okay, second part is also done without any problem. Now you look into the third one, K, E, M. K is here. It will be incremented 3. E is also here, direct incremented 3. M is also directly here. See, K, E, M, all coming in same line. Okay, all are coming in same line. So K, E, M means K3, E is also 3, M is equal to 2. Clap it. Very simple, very without any problem. M will become what? It will become 2. So 3, 3, 2. Okay, so you can see the same thing happening here. 3, 3, and 2. Okay, without any problem. This is very easy. Now you go to the next part, KMY. Now you see this. For this, we need to increment, sort of insert KMY. K is here, so this will be incremented to 4. Not a problem. Then they are talking about M. Okay, now there's a problem. See, K to M they are talking. In between there is a E. I need to go from K to M here. See, I need to go from K to M. In between there is a E. What should be done? What should be done? Very simple. I need to go create one more node for it. Which node? For M. If I create one more node for it, this is what I'm going to get. See, I'm going to create one more node with regard to M, and this is the node that has been returned like this. Okay, then they're saying you need to insert Y. So from M, be careful here. From M, you need to go for Y. Okay, from M, see, I've written M here, fine. But from M, I need to go for Y. I can't go back, through like this because there's a O in between coming. So I'll create one more node for Y so that I can go from M to Y direct like this. Okay, see now, K, M, Y. Is that KMY written? Yes. You can see very clearly this is KMY. That KMY is very clearly written here. KMY. This is something that you got to keep in mind. Creating extra nodes. Where you create extra nodes. Then you are going to insert the next one, KEO. Okay, now you see this K is here, E is here, O will be coming right here. So from E you need to go to O. Is there a path? Yes, there is a path already. You can check here very clearly that from K, E, O is already there is a path here. So you have to increment what? K here, E here, and also O can be incremented right here. Because K, E, O, easily you can increment that. So K, E and O. Okay, now you can see this K, E, O, right? So this will be easily incremented like this. 5, this will be incremented to 4, and this you can see very clearly this is becoming 2. Okay, now this is the last thing what you get. Okay, this is the last thing what you get once you sort of insert every of the ordered pattern sets. You sort of insert all the ordered pattern sets. This is what you get. You got K, E, M, O, Y. Then you got all those in one path. You got M, O, Y. Then of course there's a Y in between. Okay, so you put all those things. This is what you're going to get. Very important to know also. Now the next part. Okay, now the next part. Next part is, see, I've written all these things, right? Be careful with this. I've written all these things, right? Now I am going to put all these things in form of sets. Can't say the word of sets and all, but a very simple example, okay? That you can put it all these things in form of a set like this. How? I'm going to write for Y, because Y is at the bottom. Okay, Y is at the bottom. I am going to write a set, ordered set for this Y. How I'm going to write, please understand, then we'll again come back, then we'll see how it is being written and all. Okay, Y, for the first Y, there is written like this, K, E, M, O. And what is the one? It is, you can see this, K, E, M, O. There is one way of writing it, K, E, M, O. And what is the value of Y? 1. Is that written here? K, E, M, O with the value of 1? Yes. Now for each item, conditional pattern base is computed which path labels of the paths which lead to any node of the given item. Okay, the items in the below table are arranged in ascending order of their frequencies. Okay, what is the meaning of ascending order? You don't have to worry. You have written like this now, it will be in descending order. Now you start from bottom, obviously it will become ascending order. Okay, you start from bottom, it will become ascending order. So when you do that, okay, when you sort of do that, see this Y, K, E, M, O. What is K, E, M, O? This one, K, E, M, O. Okay, and what is the value that 1 here? This one you can see very clearly it's been written here. Then the next one, there is this one, in this Y I need to talk about now. So where does it go? It starts from K, E, O. That's all, K, E, O. And the value is only 1 again. See this, K, E, O, the value is 1. Then one more Y is there here. Okay, what is it? K, then again M, then Y. That's all. So there's only 2 things, K and M. See this, K and M. And what is the value of Y here? 1. Clearly written. Okay. Then compute with regard to O. So the first with regard to O, how do you call it? K, E, M, O1. See that same thing is written, K, E, M, O value is 1. Okay. Then the next one, O is here. So K, E, and again O. So that value is written here, K, E, and of course value is 2 is written here, because you see this, there's a value 2 here of O. Value is 2 here. Okay, so that's why is written K, E, and O. Is that all O done? Yes. Then with regard to M, K and E, M2, K and E, M2. Next, okay, with regard to this, K and just only K. Okay, just only K here. See this, from K to M, that's all, only 1 K. And what is the value? 1. Then K. What is the value of K? Where is K here? Right here. Okay, where right value is right up here. What is it? K? Sorry, E. Sorry, E value is right up here. What is the value of K from there? For E, you got only K. And what is the value of E? It is nothing but 4. Do you have to write for K? No. This is the third part you need to be careful of. Conditional pattern base. Okay. conditional pattern base. How you need to write for each and everything. Now that for each item, the conditional frequent pattern tree is built. Okay. Conditional pattern tree. See, when I'm giving it in form of a notes for you for internals or exams and all, I'll go neatly step by step, each and every step by step, just like how I'm explaining it, because these algorithms are very important. It is not just right from the data mining perspective. You need to see it from a machine learning perspective also. So even that's the reason I've taken an example which we learn exclusively when it comes to machine learning. Okay. There's just no point learning things only for the sake of VTU, that to data mining, a theory subject. You need to learn this from a point of view of machine learning, which you are going to learn in 7th sem, very important. Okay. Now you can see this is nothing but conditional pattern base. That's for that you are going to write what is the next thing. Conditional frequent pattern tree is built. Okay, it is done. How do you think it is done? It is done in a way like this. It is done by taking the set of elements which is common in all the paths in conditional pattern base. Oh, don't worry. Okay, if you don't worry the words also, you don't worry. Just by looking at it, you will understand. Okay, now this is what we got. See this conditional pattern base. This whatever the thing what we got here, I've taken right here. Okay, and also the the items for it. Y O M E K. I've taken right here. Y O M E K. I've written those values right here. Now I need to build what is known as conditional frequent pattern tree. Okay, I need to build that conditional frequent pattern tree. I need to build. How do you think you need to build that? Check for the number of. First thing is check for the number of K. Only K. How you are going to write? You need to come from bottom again. Okay, only with regard to K. How many are there? 1, 2, 3. 3 Ks are there. Written, write that. Next one, you go for the next condition. Okay, after K, K and E. See this? Below from here you have K. So next thing is K and E. Okay, check for that. K and E. K and E. How many things that you have? Okay, you got K and E, K and E. So see this? KE, KE, and where is one more KE? Here. Where is one more KE? Here. Okay, so how many got? 1, 2, 3. Okay, 1, 2, 3. That's written very clearly here. Okay, then again with regard to K. So what is this pattern about? Okay, so you can see the words that has been written here. Now for each conditional frequent pattern tree is built. It is done by taking set of elements which is common in all the paths in the conditional pattern base. What is conditional pattern base? This one. Okay, so you're going to take the ones which is common in all the paths. Common in all the paths and calculating its support count by summing up. Once again, yeah. By summing up the support counts of all the paths in the conditional pattern base. Look into this. KE, KEO, KM. Okay, so if you take K as a thing, where and all, how many times you are getting? You are getting. Are you getting the minimum support of 3? Yes. KE, are you getting a minimum support of 3? Yes. With only with regard to K, are you getting it? Yes. Okay. See the values. You can easily understand just by the values of it. Okay. See this K and K. 2 plus 1, 3. Here themselves as K. Okay. Then again KE, KE. 1 plus 1, 3. Then again KE here. KE is one more here. 1 plus 1, 2. Okay. But I'm taking only K here so that I'll get a more patterns. Okay. So K, K, K. What is it? See, what is the way of asking? Even simpler way of going it. Take the first one. Take the first one. I'm talking about the first row. Okay. KEMO, KEO, KM. What is the element which is common in all the three? Some people may say KE. Okay, KE is there in first one. I'm talking about this one. K is there in first one. It is there in second one also. What about third one? K is not there. You can't take KE. Some people may say KMO or KO. Okay. Is there K? K and O is there here? Fine. K and O is there here? Fine. What about here? It's not there. Okay, it's not there. So what needs to be done? You need to take a one which is common. It should be common. So what is the only thing that is common? There is a K here, common. There's a K here, common. There's a K here, common. I've written that K, conditional frequent pattern tree, K with a value 3. Very common. Then go for the second one, the second row represented by O. KE is there, KEM, KE. What is common? KE. How many times it's coming? Okay, you can see the values. One value is right here, 1 plus 2. 1 plus 2, 3. Okay, then next one, KEK. What is common? K. What is the value? 2 plus 1, 3. Then what is common here? Only K is there, so that K will be coming here with the value 4. So this is what you got. Okay, this is what you got. And be careful, we need to keep this. What was this minimum support? We have taken 3. You have taken a minimum support as 3. Are we getting that 3? Yes, it is either 3 or more than 3. Okay, it is either 3 or more than 3. So this is what you got. Okay, now what is the next thing? The fourth step is done. Then the fifth step. Okay, what will be the fifth step? From the conditional pattern frequent tree. Look into this. This one. Conditional frequent pattern tree. The frequent pattern rules, this one, are generated by pairing the items of conditional frequent pattern tree set to the corresponding items as given below. How? Like this. Okay, we need to pair. What is this? Whatever value that you got here now, look into this. Open. Oh, it's taking some. Yeah, now it's opening. See this? We got this K, right? This K needs to be paired with what? The items that is there. Why? This KE needs to be paired with what? O that is there. K is need to be paired with M that is there here. Okay, so that's what I'm trying to do here. See this? Now you can understand what is the word that's been saying. From the conditional pattern tree, which is here, the frequent pattern rules, these ones, are generated, okay, by pairing the conditional icon pattern tree set to the corresponding item. What's corresponding item? Y, O, M, E, K, and O. That you are going to pair it off. If you pair, this is what you get. K and Y with value 3 or greater than 3. Okay, then you can see this one, KE. So there's O. Okay, KE and also there's O there. Okay, that's what is written. K and O, E and O, because you get 3 things now, K, E, O. So you need to do what is known as permutations of it. Okay, permutations of it. What are the way of doing it? Okay, K, O is one way, E, O is one way, K, E is one way. Okay, K-O, E-O, E-K-O. Sorry, not K-E, E-K-O. All taken together. And you can see very clearly the values that have been written. Okay, very clearly the values are written with regard and same values. Whatever 333 that is there, that's only written here. No changes and all. 333, that's one very clearly written here. And then go for the next one. Okay, M, K and M, 3. Okay, see, it is only, it's written like this. There's no, what do you call, greater than, lesser than, and all. Just a symbol like that. If that whiteboard opens, I'll tell I'll show you. Okay, how it's all done and all. So it's just a symbol there. Okay, nothing more to be greater than, equal than, just a symbol. Okay. Now you see next one. E, where is it? Next, last one. E and K. E and K with 4. Okay, it should be written 4, right? Yeah. See, E and K. Last one will be left out like that only. Okay, this one, for each row, 2 types of association rules can be inferred. For example, okay, for the first row, you can look into this. Look into this for the first row. Okay, inferred for the example for the first row, which contains the elements K to Y or Y to K. It can be K to Y and of course Y to K. Okay, that can be inferred for the first one. To determine the valued rule, what we are going to do? The confidence of both the rules is calculated. Okay, the confidence level. What is the way of calculating a confidence level? You studied for many classes back. when you talk about what is minimum support level, confidence, minimum confidence, all those things. Okay, this is one of what I'm talking about, the first parts of your module 3. Confidence of both the rules is calculated. One with the confidence greater than or equal to the minimum confidence level is retained. Okay, so that will be what is known as, if you can write till right here, the entire algorithm is all fully done. Okay, this is what is known as, see, I've taken an example right from machine learning point of view itself for you to sort of understand. Okay, till here, whatever you get, the frequent pattern generated. What was the the algorithm name called? The algorithm's names was frequent pattern. Okay, FP, frequent pattern growth algorithm. Did we grow with it? Yes. Okay, till here we got that entire frequent pattern. And you can see very clearly how the frequent patterns come. K and Y, they come together with 3. Okay, K and O, if you take 3, E and O 3, EKO 3, KM 3, EK is also 3. Okay, like this, it should be 4, right? K, E and K should be 4. Okay, it should be written as 4. Okay, E and K. Anyway, be written. Okay, now that is why you're going with what is known as this FP growth algorithm. Very important. There's all this writing of diagrams, all those things and all. If they themselves will give this example, generally they go with this example. Where is that example? Yeah, this example. If they themselves go with this example and they want you to figure out what is known as the FP growth algorithm for you, you should be able to neatly do it. Okay, you should be able to neatly do it without any problem. And it's a 10-mark question. Okay, it easily come for 10 marks or not less than that. Okay, that's something that you got to keep in mind, that it will be coming for 10 marks. Okay, so what is the thing that you got? It was, what was the prerequisites? A algorithm. What are the other prerequisites? The tree data structure. You don't need to have tree data structure, you just have to know how to sort of build those trees. Okay, so what is the primary drawbacks of a priori algorithm and how do you overcome that using the FP growth algorithm? To overcome these redundant steps, what redundant steps? The ones you see here. Okay, a new association rule mining algorithm was developed by the name frequent pattern growth algorithm. And what does it do? It overcomes the disadvantages of the a priori algorithms. Okay, look into this. Overcomes the advantages of a priori algorithm, disadvantages of a priori algorithm by doing what? By storing all the transactions in tree data structure. You're going to store all those transactions in tree data structures. Okay, and here what is the most important part? You're only scanning the database once. The scanning of database will be done only once. There's no need for doing it again and again. Okay, so like this, we are going to, I think in the next class, we are probably going to take one more example, not just one, probably we're going to take 2 examples. Okay, 2 examples, and you can see this one also. This is the the ones that is there in your test book, right? So we are going to take this example also. Very important to know the textbook examples. Okay, so this example for the transaction data set, what is being given here? How many transactions you have? You got 10 transactions, and with all the items A, B, C, D, E. Okay, 5 items and all the transactions. For this, you keep on doing what is known as the entire steps. Based on the entire steps, you'll be keep on going on doing things. Okay, if possible. Okay, if possible, instead of writing like this, I'll try to give written notes for it. Okay, I'll be solving on my own, just using our own steps and all. I'll sort of give that as written notes. I'll convert that into PDF. Will be joining along with your PPT. It will be nice. Okay, so that even the written notes probably will be able to understand, because in this some people may not understand. Of course, you need to use the lectures of the recorded lectures to sort of understand things. So some people may sort of miss this, may not understand each and every step. So for that, I'll try to do that. Okay, with regard to written notes and all, and it will be pretty nice, right? So we are going to take 2 more examples, because again, this is very important for your 7th sem also. So in detail we'll learn. Okay, 2 more examples we'll learn. Then of course you will be having end up with only 2 things that will be there in your 3rd module. Okay, probably we're going to complete that. In 4th module, we're going to see at least two topics. a fourth module before we move into the second intervals. Okay, fine. In the next class, we'll meet and we'll discuss about the other two examples of FP growth.